Hello guys, welcome back. Today in this video tutorial I will be taking a new proximity sensor, that is TMD2771. Now to have a better perspective regarding the sensor, let's visit the website, that is controleverything.com, and here we have to search for this particular sensor and let's see what we got else from that. And as you can see, it's an ambient light sensor with 16-bit proximity detection, and these are some of its more prominent features which you can see on my screen. You can also have the ability to purchase the sensor from this website from here. Well, I will be interfacing the sensor TMD2771 with a Raspberry Pi and a Python code, and for that let's go to resource tab, and here comes the Python code sample. Now you can download the Python code sample as a zip file from this very site, and you can also have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware connections we need to set up, and let's proceed. In the hardware section, first of all, the requirement is of a Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Now this here is an I2C Shield. It's available on the website controleverything.com, and the real reason we are using is to make easy connections with other I2C devices. So gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we require our sensor, that's a proximity and ambient light sensor TMD2771. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C Shield. Now we require to power up our Raspberry Pi, and for that a micro USB cable comes handy. Now gently insert it over the power jack. Now the last part is to provide internet connection, and there are two mediums. First medium is Ethernet cable or a LAN cable, as you can see, and gently insert it over the Ethernet jack. The second part is a wireless USB nano adapter, which you are able to see on my screen. Now these are the final connections we need to set up our device with the sensor. Now what do we require is to have a look over the code, and let's interface it with that. Now for the interfacing part, what do we require is to have a look over the Python code, and for that, to get it, log into github.com, and here we have to search for the repository, that is Control Everything Community, and let's see what we got here. This is the sensor TMD2771, and this here is our Python code. But let's have a look over the instructions we need to fulfill first. It says that we have to download and install SMBus library on the Raspberry Pi, and the steps to install SMBus are provided here. Now this link, open up this link to have a better perspective regarding the instructions, the commands. Please note them down and do the installation carefully. Now this is the command to run the code. Please note it down also. Now this is our Python code. As you can see, it's a .py extension file. Now in the code we have imported SMBus and time libraries, and we have the address of the sensor, that is 0x39. Now in the writing section part, there are some commands which I will elaborate. As you can see, we have selected enable register 0x00 or with command register 0xa0, and we are sending a command, that is 0x0f for power on, wait enable, proximity enable, ALS enable. The command is here. Now we are selecting ALS time register 0x01 or with command register 0xa0, and we are sending a command for 0xdb, which will be A time for 101 millisecond, and writing command is here. Then we are selecting proximity ADC time register 0x02 or with command register 0xa0, and we are sending a command that will be 0xff for P time equal to 2.72 millisecond. Writing command is here. Then we are selecting wait time register 0x03 or with command register 0xa0, and it will be 0xff the command for W time equal to 2.72 millisecond. This is here the right data, as you can see. Now we are selecting pulse count register 0x0 or with command register 0xa0, and we are sending the command for 0x04 with pulse count equal to 4, and this is the writing command. In the last writing command, we are selecting control register 0x0f or with command register 0xa0, and we are sending the data that will be 0x20, that for 120 milliampere LED strength, proximity uses channel 1 diode, proximity and ALS each gain will be 1x, and the writing command is here. Now after these many writing commands, we want to read the data back from the sensor. As you can see, we are reading the data back from the sensor from the register 0x14, or with command register 0xa0, we are reading 6 bytes of data, as you can see, channel 0, channel 1 data along with the proximity data. So here the conversion of the data takes place along with some of the formulas and conditions which are applied and clearly described in the datasheet for TMD2771. At the very end of our code, we have the output data to be displayed on the screen, as you can see on my screen, and it will be ambient light luminance in lux and proximity of the device. So it's a very simple and generalized code, as you can see on my screen. Now what do we require is to have a look over the practicality and see how the sensor responds and works. Well, for the working environment, first of all, the step is to copy this entire code of the Python, as you can see on my screen. And now open up the terminal for the Raspberry Pi here, and here create a new file, as you can see on my screen. .py will be the extension, and after that we have to paste the entire code here, and then we have to save it. And this is the command, as you can see on my screen, and here we go. As you can see, we have the ambient light luminance and the proximity of the device. As I am running the command again and again, you can see there is a very small change regarding the values, but when I place some object over the sensor, you can notice the ambient light luminance decreasing and the proximity of the device increasing to the maximum value, that is 1023. But instead, when I bring a light source near the sensor and run the command, you can see the increase in ambient light luminance and there is a change in proximity of the device. So this is how the sensor responds. Now what we require is to have a look over the benefits, features and the applications of the sensor. Let's have it. The TMD2771 family of devices provides digital ambient light sensing ALS, a complete proximity detection system and digital interface logic in a single 8-pin package. The proximity detector includes a digital proximity sensor, LED driver and IR LED, which are trimmed to eliminate the need for end equipment calibration due to component variations. Excellent background light rejection allows the device to operate in environments from sunlight to dark rooms. These features make it very useful for applications like cell phone backlight dimming, cell phone touchscreen disable, notebook monitor security, automatic speakerphone enable, and a lot many. This sensor can be purchased from the website controleverything.com, and you can have the code from the source tab, and after that you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would make it clear that for any further queries, you can reach us on controleverything.com, and to post your comments, you can post on the community page. For blogs and articles which are relevant to this sensor and the code and the video, you can go to instructables.com, and to subscribe more video tutorials just like this, you can have a look upon our YouTube channel. I hope you enjoyed this video, and thanks a lot for watching.